Welcome, everybody, to Dallas Personal Robotics Group, Robot Builders Night Virtual for March 10th, 2026. Tonight, we will do our usual robot presentations and then open it up to questions and open mic. Start off our meeting with a little bit of housekeeping. We have coming up on May 24th weekend, I believe it is, robotics competition, our Roborama, and we will be doing the following competitions if there's participants. So we're looking at quick trip, line following advanced, barrel racing, 6-can, 4-square, and Sumo. So it's a good set of challenges if people want to get a robot and show up at the Dallas Makerspace. And I believe it's the long weekend. It'll be the Saturday. And after that, I have Doug with an announcement about another competition possibly in the works.
Okay. Several of us were emailed from a gentleman who is at Dallas College Eastfield, which is inside of LBJ, I believe, and
south of Dallas,
for a line following parade on Saturday, April 11th. Okay, so I'm going to go over the rules so you can kind of see what type, and they just said when they sent the initial, it kind of said that I hope your members could attend. There is no cost, and it would be a great event for all skill levels. All right, so with that, I sent him a question asking, well, is the event open to participation, or is this an invitation to watch only? And he said, no, it's open to everybody. So you might ask, what is the line following parade? Okay, well, apparently, and he did show me he did include a little video. I don't know if I can get it to, and I can't find it right now in my email, but essentially it was it wasn't a very sophisticated line follower. It was using, I think, a one sensor bounce off the line type of line following, but that wasn't the real point of it. It was like a parade float. Okay, so you essentially create like a parade float, and we'll look at the rules in a minute, but essentially you have to be able to maintain a distance in front of you and a distance behind you, and you have to go at a certain speed. And I think that you're judged on how cool your robot is. Okay. So, I was thinking, well, we could have something that has a flat platform with, LEDs on it and lights, maybe some mechanical things that were moving and stuff, and maybe a sign over the top that said DPRG. And it would be a fun thing because we don't usually worry about distance in front and distance in back. So that would be kind of interesting, new kind of a problem, but it wouldn't be too hard. And so I'm thinking that, this might be fun for a group project for the club to do one of these little robot floats, I guess. So I'm going to go to, let's see if I can find it, sharing, and I'll do the entire screen. And And so here's their flyer. And you can see there, that's a, I can't remember the Parallax, a Parallax robot. I'm not sure what version that is. And, but I wish I could find the one that they showed us, the little float. And here is the rules. Okay, so the machines must follow the line reliably.
I'm not seeing the rules back. I'm still seeing the email.
Oh, it's not showing this? What's it showing?
Your
Oh, it's
email.
showing me.
Yeah.
On your first tab in your email.
I
About
guess you have
1,000
to.
tabs.
All right, let me,
Got to select another tab, I think.
maybe I have to open up another share window. Okay, I think this one will do it. Now do you see it?
Yep.
Okay. All right, so they must follow the line reliably. Machines must be designed, built, and tested prior to the event. Otherwise, no last minute tweaking, I guess. It's a black line on a white background, standard electrical tape. Robot length, width, and height. You can see 28 centimeters is almost 12 inches, I believe. For you metric people, how much is 28 centimeters? I don't know. It's long. So think of it like, I think it's kind of like a
30 is a foot,
boxcar type format. You know what I mean? It's a big rectangle. Let's see, 28 by 22 by 36. Maybe it's the 36. 36 is height.
Hey, yeah.
Yeah. So
Pretty
each
tall.
robot has to have a rigid white rear bumper, approximately 35 from the rolling surface. So you got to have probably a piece of foam board. And then it gives a dimension for the rear bumper.
Mm-hmm.
And then each machine has to have a sensor mounted on the front to pause motion using timer to prevent collision. It could be a limit switch, infrared, ultrasonic. We would probably use a TOF sensor, if I would think.
Yeah.
And let's see. And I think it says even though it says on the rear bumper, I take this to mean that it needs a sensor on both the front and rear. Okay, which kind of makes sense. And they may carry or tow a float. So they're thinking of this as a parade. And so I think the robot body itself should be the float. And that was the example that they showed in their video. They can have lights, music, visual displays, whatever you want. They got to be built with electronics. So they can't be mechanical, I guess. And that's pretty much it. I don't know why this is not. Somehow I'm in a markup mode. I don't know. Not in a mouse mode. Well, anyway.
Yeah.
So it's on the 11th. Could be a lot of fun. Wouldn't take much. You give some people a chance to do something. It kind of reminds me of Robbie on a miniature scale. And like I said, I wish I could find the give me just a second here and I'll
There was the flyer that's attached to the email, Doug, but that's all I saw there.
Yeah, it is. But there's some place he actually had a video of one of these robots. And it was pretty crude, but it was interesting. So anyway, that's about a month out, and we could probably knock it out pretty quick. That would be one thing.
Yeah.
And so that was the major thing I wanted to show people. And then I guess the other thing, I'm going to stop sharing somehow. Oh, here it is. All right, I should have stopped sharing now.
Yep.
And I'm gonna try and find that thing, and I'll break in if I find it. The other thing was, if anybody here has a CNC router or is planning on a CNC router or anything like that, the people who make to make a Lightburn, which is the top version of the laser software. So if you have a CO2 laser, or if you've gone down to the makerspace, you've used Lightburn. Well, that company is now making something called Mage, and so they're expanding their lines to take on CNC mills, and their Lightburn product was really good. And one of the nice advantages of this would be that you would have the same tools in both programs, and might be a little bit better might be a little easier learning curve. So that was something that, and also their model is different. It's, I think you purchase it and it's yours for 1 year. It's yours forever, but you have updates for a year, and you can, and I suspect that they'll have 2 modes. There'll be a basic mode, which is for 2D milling, which will be about $100. And then there'll be one that has a lot of slick bells and whistles, and that one will be like V groove, V carving, and things like that, and that'll be $200. And like I say, you buy it once and it's yours. You don't have to worry about it, and they update it for a year. So anyway, it's a potential new player, could be disruptive in that market, because the CAD people have been kind of fat and easy for a long time. So anyway, that's all. I'm turning it back to you.
Yeah, that reminds me, I need to go re-up my Lightburn, because it's cheap to re-up it, but it's not so cheap. It's not as cheap to then have to rebuy again if you don't re-up it all the time.
Oh, no, I think an update is $60, Harold. And it doesn't matter whether you have the Pro or the basic. So it's very fair. The company.
Yeah, I think it's a good price for the stuff you get and all that it does. There's no doubt about that. It just, if I don't got to spend an extra $30, I can spend it on doing something else. There's lots of things I can buy for $30, that I get to play with. So,
But you own it forever. So if you're happy, you're fat and happy with what you got, you don't need to update it. But there'll always be one feature that they add that you will.
There will be, won't there?
This year they're looking at true nesting. What does that mean? That means you push a button and all your parts that you got on your plate essentially minimize the material you need.
That's pretty cool. So, it's taking kerf and laser and all that kind of stuff into play and all that. That's pretty cool. Maximize your space usage so you don't have to do it.
Yeah. Yeah.
So is this on like the Shapeco or Nextcarve or?
That's what this Mage is aimed at. That's
Okay.
right.
Yeah.
Or what God. Yeah, any of those
That size.
SandSmart or any of those, that make CNCs. That's what they're aiming at. And the big boys on the block have been whoever makes V-Carve. I don't know the company name. And then there's another one. There's two companies that pretty much have most of the market, other than the people that are doing it with FreeCAD or whatever the real expensive one is, Fusion 360. But those have a really steep learning curve. But the two hobby side gig ones, there's one of them subscription, and so you're paying out every month, and then the other one has you buy it, and then when you want to buy you rebuy it, but at a discounted price. So I don't know. So this one, like I say, this might be disruptive. It'll be interesting to see. Oh, okay, Pat, it's all yours.
Thanks, Doug. Next up, we got Mark.
So I was just going to share a little bit of what Mark and I got together last Wednesday at the Dallas Makerspace and kind of went over Robbie. And mainly it was me going over Robbie and having Mark be my guide. But we kind of went over all of the electrical diagrams and whatnot that Paul had done. And one of the main things that we wanted to do that Mark was interested in doing was in cleaning up the power, because currently on Robbie there's several different power supplies. All of them are different wall warts and stuff of that sort. And so there's 12 volt, 5 volt, a 19 volt, 9 volt. And so there are several different voltages running throughout him currently. And so we started taking a closer look at what all of those voltages were used for. And we think, with the one exception of the 19 volt, which was going to a motor in the neck, we think we can actually switch everything over to 12 volt and 5 volt. So we can basically simplify the power to him quite a bit. And so those were some of the main things that we discussed. And one of the things that came out of that is we would probably need to change out the neck mechanism a little bit to so that we could get rid of that motor that was up there that was requiring the 19 volts. Because that's kind of the odd man out. The 9 volts were being used for powering the Arduino Megas and the Arduino that are in there, but those can also be powered off of 12 volt, so we can simplify that and just run 12 volt to the Arduinos. And then all the other motors, most of the other motors were getting 12 volt, except for the servos that are used in certain places, and the servos are all 5 or 6 volt. I think they're running off of 5 volt currently. So we think we can simplify the power quite a bit, which will clean up that central cavity in them and make things look a lot nicer. Mechanically and all of that, everything looked like it was in pretty good shape. So I think if we can clean up the power and whatnot, that would be good. So one of the things that I offered to do is kind of a redesign on the neck mechanism to clean that up and swap out the motors that are up there and just use stepper motors or something like that we can easily run off of the 12 volts. And so, so yesterday I had a little bit of free time, so I took a stab at building up a design. And so I can show that. I'll show the CAD model first.
Yeah, because right now he has a motor in his gut, basically, that controls his left to right head motion with a long screw rod that goes up through the torso. So, yeah, it's a good little design that Mark's got. So
is he not going to be able to do head banging anymore, or what?
oh, he'll be head banging more. He'll have a lot more motion, I hope. Yeah.
Thought maybe he'd be kind of stiff, you know.
Gonna-
Why are you not showing me the?
We're going to try putting in some NEMA 17 steppers into his pan and tilt. So hopefully they should be more than enough to give us
torque,
nice fluid motion. Yeah.
You don't want his head to.
Oh, I'm trying to load up my CAD and I'm not seeing it show up in the list of windows to share.
Might have to share the whole desktop.
There we go. So let me take off the cover here.
Yeah, so currently his neck is made of a 4-inch PVC pipe. So that's why it's substantial there.
Okay. So this is a company that I came up with. Kind of works with the same type of interference, same type of connection that's currently used in the top of his head, which is the slot up here. And then it basically has 2 stepper motors driving gears to give him rotation, to rotate his head on the neck, and then also tilt on the head, which is basically mimicking what he has already.
Yep.
So are you milling PVC pipe, or is that all 3D printed?
3D printed.
Okay.
Got to prototype it first.
So I figured it would be easier to just 3D print rather than trying to mill the pipe. And these days, 3D printing is a little bit more accessible than it was back when Robbie was originally built. So anyhow, this is it's kind of the design.
That's cool. I'm excited.
And
Looks good.
and here's the
Oh, look at that.
Yeah, you already
3D printed version,
Of course, you already printed it.
minus the steppers. So
That looks great, Mark.
so basically, bearing in the bottom for spinning, driven on the gear here. So the stepper, in this case, the stepper motor will rotate around the gear.
Hmm.
And then the top will have the stepper motor for basically controlling the tilt. And so still need to go into for the next meeting and then make sure that get the heights right and all of that.
Looks about right.
But
How big of a stepper is it?
I think
What's
like NEMA
17.
17s should be enough.
actually, to make it fit in this design, I actually cut them down to NEMA 11s.
Oh,
Okay.
I don't think I have any. Do you have any 11s, Mark?
Okay.
What's that?
Do you have any 11s?
Yes.
I don't know. Okay. I have some 17s. I don't have any 11s.
Yeah. Because that's great. Because like a stepper, you have a feedback, so you know what position you're at.
Right.
Okay. Yeah.
Yep. Hopefully you can join us next time, Mike, when we get together.
You said you do
Anyone
have feedback on your steppers?
What's that?
Did you say you had feedback on the steppers?
Well, what we'll do on what I was planning on doing was once we figure out what we want the tilt limits to be and the rotation limits to be, we can put stops into the model so it'll stop. And then we can use sensorless homing by essentially detecting the stall current on the stepper.
Oh.
So we can run it to the extremes, hit the stops, basically use the stall on the motor to set the homing position, and then we can automatically calibrate it for moving it. I wasn't planning on putting in any sensors for being able to sense the position. I was going to leave it open loop, but we could put in some angle sensors in there easily enough if
Mhm.
we wanted to.
Or 2 switches.
Yeah.
The steppers have a precise step size, so
Mhm.
yeah,
Right.
you can easily control it. Yeah.
Yeah. Once we have a home position, we can easily set the position, and there's not much weight that it's moving around. So
It's very cool.
So what are you going to do with all that space in the body of the robot if the motor is missing?
Lights and sound, AI.
okay.
in there, yeah. Have a little door that opens. No, little guy in there pulling strings.
Well,
That's where the
probably
microwave goes.
There you go.
you probably want to get some sort of arm on the other side too. You know, besides just a static arm.
Yeah.
So,
Yeah, and we
I
have
don't know
the,
if you want to go to the extreme that Will did when he built that, but you know,
it's impressive. I don't know if we can
yeah,
replicate it.
but you could come up with something.
Yeah, and we have the version 2 elbow to install as well.
So what did you print that in, Mark?
oh, this I just printed in PLA for
PLA?
just to make sure dimensions and whatnot were more or less right.
Yeah.
For the
Mhm.
final one, we'd probably want to use something more like ASA or PET-G,
Mhm.
something that would handle being put in a car for when we're transporting it.
Yeah. Is this going to have your trademark BB bearings?
Yeah, it has those in it at the moment.
It does. Cool.
It doesn't have to have it, but it has them.
Yeah.
I've got so it's got the bearing on the bottom for
Oh, there you
the
go. Mm-hmm.
for the moving, and then it also has clamped bearings up here as well. So I don't know if you can see it too well, but essentially there's
Mm.
this
Oh,
gear fits a little loose at the moment, but it can be glued in place, or I can make it fit better. But then there's bearing clamps here, so there's 2 bearings that are on either side of this guy so that he moves freely.
Got it. Cool.
Yeah, you're gonna have to buy those the balls wholesale, I guess. You've used a lot of them. Huh?
You get like
I've been
1,000 for a couple
I've
bucks.
been using this same bottle for about 5 years now.
Oh, really?
That's
Are you
cool.
recycling them though? You know,
Sometimes. Usually it's more hassle than it's worth to recycle them.
Mhm.
Once you build them up, they're kind of hard to take apart without taking a saw in there to cut the race.
Just take a hammer.
that's kind of neat.
So that's basically what I had. I didn't know if you had anything else to add, Mark.
Mm-mm. I have not had a chance to work on it, but I really want to get the wiring schematics that Paul drew up into like a CAD software, like KiCad or something, just to make it look cleaner and more readable. I think from there we can translate it easier into what we need. But I'll try and get on that before we next meet, which should be what, next Wednesday? Yeah, next Wednesday, right? Yeah.
If you're trying to do every 2 weeks, yeah.
Yeah. We can do more if needed. Or if we want to get together and build Doug's parade float.
Yeah, I wonder if you could do like get an MP3 player and have him, you know, rock to the music, you know, just tilt his head.
Oh yeah.
They still have the Cylon
Yep.
light.
And he's got a light in his chest now as well, some neopixels in his chest.
Yeah.
So
But if you could get the Cylon to jump around to music, like a VU meter or something. You know?
to get a nice
Fast,
little
I
head.
can't hear you.
Oh, you can't hear me?
Pat. We can't hear Pat.
Oh,
Oh yeah, Pat is muted beyond muted, unmuted muted. Did your microphone come unplugged? Uh-oh. I bet that's what you get for having a permanent summertime hours. You're saying that British Columbia have officially adopted the summertime hours permanently now. No more time changes.
Can you guys hear me now?
Yes.
Yep.
Welcome back.
Don't know what happened. Never hit the mute. It's just the miracle of Windows. I was saying, did you consider putting an 8-track tape player in his chest?
Ooh.
Well, now we're getting really modern.
Ticker tape.
Ticker tape. There you go. Well, thanks, Mark. Mark and Mark, I guess.
Marky Mark. Yep.
So that was it for our list of presenters. Tom did have, I think, a small update he was going to do.
Yep. And we had a few other people join since then as well. I don't know if Kareem, if you had anything or.
No, I'm not sharing anything tonight. It's just my massive wit.
So I can talk a little bit about my 2 current projects. Just going to share a window here with another camera in it. See how that works. How's that working?
Good.
Mhm.
Can you see the picture? Because I can't.
Yes.
Yeah.
Yeah.
Keyboard.
A keyboard and some blue printed parts and wires.
Yep.
Yep.
All right. So
Soft, natural keyboard and natural.
it has a PS2 connector on it.
Wow.
a little bit.
I used to have one of those.
Yep.
Or a few of those.
And I
yeah.
love it. The feel is so good.
It is good.
That used to be my favorite keyboard.
I have 2 or 3 of them.
Mine all broke over time.
Well, I have 2 or 3 of them because if they break, I want to plug in another one just like it. So when I went through my year-end get rid of stuff, I hung on to these. I posted a bunch of other keyboards for sale, some of which have sold, much older. But I could hang on to these ones because I like them a lot. I like them better than the USB interfaced keyboards I've got, which have a kind of a cheap, lightweight feel to them. Anyway, but that's not what this is about. This is about the Sesame robot that I'm in the process of working on. Here's the, whoops, I don't have the legs screwed on yet because you leave them off.
Keyboard a little bit, Tom.
How's that?
Perfect.
A little better?
Yeah.
So I have all 4 of them. You can see the other legs, leg sections sitting over here. They're all put together, and there's a tale to tell about putting those together. These go in, they will turn 90 degrees as they're supposed to, but the calibration is still required. Now, let me just take this little guy off for a minute. This is the work I've done so far on developing my own, basically my switchboard to hold the ESP32, which runs this whole thing. It's sitting here underneath a collection of wires, which are used to connect the ESP32 over to the array of pins to hook up the servos. This next array of pins is simply a couple of I2C plugs, one of which is used for the display. There's a little display, which they make a standard part of the system. The original design places a power switch on the back end of the upper case. I've moved that power switch to the top of this end. And all I did was I cut the 3D printed design, leaving about 3 centimeters on the front, because I wanted to be able to get at the internal electronics and still be able to get at a power switch and a display, and to do some of the mechanical messing around that's required in order to get a circuit board that will fit. This is just a piece of perf board cut to size with some holes in it to hold all the little bits. And I found out that just having the front end wasn't enough. So I also 3D printed this, and those of you who have looked at the design will recognize that this is about the bottom ½ inch of the top section. And I did that just so I would know what size the circuit board would be so that I could still put it all together like that, screw it down, and the circuit board would fit along with everything else. That turned out to be a really quick and simple template device to help me make the circuit board right. So for those of you who are building your own circuit board, that was a really valuable thing to do that doesn't take long to print. I have taken the design for the top part and stretched it another quarter of an inch higher. I haven't printed it yet, but when I get around to it, then it'll give me a little bit more room to put all of these doggone wires in place. I'm going to pull these legs off now because you've seen the net effect of the legs. If you're going to build these things, there's some interesting things to be aware of on the part which is called the femur. Just make sure that's focus on my. Can you see that?
Mm-hmm.
Okay. What you're looking at is the black control arm that fits on top of the servos that came with the. I bought the steel geared or aluminum geared 9-gram servos to put this together after watching some videos that argued that the metal geared 9-gram servos are superior to the plastic ones. I have tons of plastic ones, but then I bought some just for this project. Those are really, really nice little lever arms, and they are exactly the right shape horizontally in the X and Y dimension for placing on these 3D printed parts. The problem is that, let's see if you can see any of this, probably maybe not. The problem is going to be that the shallow, I can never tell what I'm pointing at here. There, how's that? The shallow inset that arm goes into in the 3D printed part is expecting a flat bottomed servo arm. These servo arms are not flat bottomed.
Yep.
And you have to have them at 90 degrees. Otherwise, there's so little clearance here, you'll be in big trouble. So, and plus you'll also have to find some little tiny screws to hold them in place with. You can see I've got screws with little washers on the top of them to hold them in place. So I went through my entire collection. I save all kinds of crap. I went through my entire collection of little tiny washers and never found anything that would work. So I said, the hell with that. And I 3D printed a bunch of little tiny rectangular shaped. Actually, they're shaped to fit the angular shape of this thing. After measuring, I needed something 1.5 millimeters high. I 3D printed them. It took about 5 minutes to do 10 of them. And my God, is it a good solution? So if you have the same control arms I have, that solution was perfect. A little 5 millimeter by 6 millimeter by 1.5 millimeter thing with a 2 millimeter hole in it. And in 5 minutes, you've got a handful of perfect little washers that solve that problem. Now on to the next interesting little problem. Let me show the servo. The servos come with a 2.5 millimeter bolt, 3 millimeters long. It goes in the hole on the top of the spindle on the servo. And that holds the servo arm on and does a really, really good job. The problem is the design requires that see where this will go, requires that the bolt that holds the legs onto the servos has to actually go down through the plastic.
Yeah.
And then through the servo arm and then into the top of the axle. So the little 3 millimeter jobbies that came with it won't do it. Again, fortunately, I have a junk box, a little junk drawer full of every little tiny bolt that I've ever seen in my life. I went through them until I found some 8 millimeter by 2.5 millimeter bolts, which are perfect for the job. But they don't tell you that anywhere in the instructions that you're going to have to do that. So you may want to plan that one ahead unless you have a plentiful supply of 2.5 millimeter bolts. That won't be any fun otherwise.
I found that issue too.
Oh, you found it already, eh?
Oh yeah. If you do dig through the GitHub, there's some building like notes in there, and one of them does have a link to M2.5 by a random amount on Amazon. So I just bought some.
I guess I'm a little naive. I expected the bill of materials to tell me that, and it doesn't. And I never found it in the build instructions for the hardware.
Yeah, but you're right. Yeah, because that plastic adds about 4 or 5 millimeters of material, so you got to have long screws.
Yeah.
But I did like the way that the body servos fitted the little method of attaching those servos was very ingenious. How you put them in sideways and then rotate them once they're in.
Yeah, everything has gone together perfectly, apart from the little gotcha with the servo arm. So I'm really, really happy with it. As I was saying at the beginning of the meeting, the guy who did all of the 3D print design, who describes the detail he went through and the number of iterations he went through to try and get this to work, in order to make it easily printable in PLA, did an outstanding job. I'm really, really impressed. I mean, I've done enough 3D design and printing to recognize that that's hard to do. He's good at this.
That's really good. What are you using for a power source? What battery are you going to use? Or are you going to use
anything?
Umbilical?
So he provides this little well in the bottom and a matching print cover to go over it if you're willing to use the little 14400 lithium ion cells. And then you get to stick a voltage converter, switch mode voltage converter in to convert down to 5 volts. I don't have any of those, despite my wealth of junk. and they're a little pricey on Amazon. And so I said, I must be able to use some of the wealth of batteries I've got. At one point, I was going to use some AAA nickel metal hydride batteries. Either 2 of them with a voltage regulator, voltage converter, or 4 of them without a voltage regulator. What I've decided, assuming I don't run into a weight problem, is I'm simply going to use those. Those are AA's, nickel metal hydride. These happen to be Amazon, which are quite good. The Amazon preferred batteries. So I'm going to use 2 of these. And I'm not going to put a voltage regulator in because I did enough research and
that should be fine.
The voltage regulator on the ESP32 is rated max 6.5 volts. And these batteries will not go above 6 volts. So I'm pretty happy with that arrangement. Happy enough that I have begun to look at how to add some integral charging connector to this thing. So I don't even have to take the batteries out to charge them. We'll see how well that works. The problem I've just done this today. The problem I'm playing with is, see how close that connector is to the servo. I suspect it may interfere with the edge of the arm because, or the edge of the leg, because these things are really tight in here.
Yeah, it will. Yeah. I wonder if you could put it on top next to, shift the switch along and put it next to the switch.
Exactly. Plan B is exactly that. Move the switch over and put it on top, or on the back. I can put it on the back because I'm not putting the power switch on the back. I moved it from there, but I could always put it back there. So we'll see. So somehow I've got to work on the process of getting all these wires cut in here, because I don't want to cut the servo wires.
No, I thought about that. I might extend the roof on mine, make it a little taller.
Yeah, I recommend that. I think that'll be easy to do.
Yeah.
So anyway, at this point, it's coming together nicely. Another few days, I might even have it walking. We'll see.
Cool.
So is there a picture of the completed piece?
Sure, I'll show you that. Let me get rid of stop sharing.
I put a link in the chat. It's the very first message in chat.
Oh.
But yeah, Tom's got the links.
I think I have it right here. Let me have a look and see. No, I better pull it over here so I can see what I'm doing.
Okay. I see it.
We'll share it with. Let's go sharing again. Window. This one. See if you can see that. Sure, the picture is, where is it? Can you see it?
Yep.
Okay, so there it is. It's an interesting little robot. This is the Hackaday article, and there's a few more things in the GitHub as well you can look at, scattered throughout the GitHub, which is fairly complex. So it's going to be intriguing. I added a second I2C connector to the board, the perf board that I put together, because I'm thinking I should put an IMU on this thing as well, and maybe it'll have some directional ability of its own. Because if I do that, I'll probably have to put some sensors on it so it doesn't walk into stuff, and goodness knows what I can add to it before it stops running. The little bit of a description I've looked at for the code suggests that the code should be relatively straightforward to modify to add additional functionality that's relatively straightforward. Things like sampling sensors.
Yeah, I looked at the code. The code was pretty good. You can connect to it with a remote device like a phone, and it'll have options in there to do stuff. So I'm excited. But yeah, I started work on my board as well, Tom. So it's a little big, like it's too wide for the machine. But yeah, I had a little 5-volt converter in there on the bottom.
Okay, so you put one in.
Yep. And then the servo, and then this one at the top is for the.
That's where this little part was so valuable as a template of how my circuit board was coming together.
Yeah, and a brief glance at the ugly underneath, which you don't want to look at, but yeah, it works. Like, I mean, there's like no short circuits in there, so yeah, I just got to do some cable management because yeah, it's a mess. But hopefully next week I'll have a bot as well.
Anybody else building one? Not yet.
No takers? Nah.
I don't have enough time to do what I'm doing.
That's true. Yeah.
So I'm being cheap. Most of my computers, and I have lots of them, my desktops were not Windows 11 capable. And I figured I better get at least one because I still have Windows apps I want to use. So I went shopping online on Marketplace, found a local guy who is taking stuff that's off lease in companies he works at, checking them out and reselling them. So I picked myself up a small form factor Lenovo for about $80 Canadian with 8 gig of memory in it. And I promptly brought it up to 32 gig of memory after our discussions here several weeks ago that suggested that even though I'm happy with 16, if I wanted to do anything more sophisticated like virtual machines, I should add more. The computer came with Windows 11 Pro installed and authorized, and it also came with a solid state main drive, a 240 gig drive. And I thought, geez, for $80 Canadian, that's pretty good. Plus the 120 I added in memory since memory's gotten so expensive. $200. And then I had a 1 terabyte real hard drive, 3.5-inch hard drive kicking around. So I added a secondary drive. So it's got a 1 terabyte data drive on it as well. The thing will drive 3 displays simultaneously. So far, all I run is 2 because that's all I have. So I'm looking forward to running 3 displays as well. Right now, I'm simply at the point of putting the applications back on it that I really, really, really want and figuring out how to move my data across without messing anything up. But it's been a fun exercise and it's been dirt cheap, $200.
That's always good.
For me, it is. That's part of the challenge, right? How inexpensively can I do this? I'll spend $1,000 for my wife's computer, but not for mine.
That's about what I just paid for a Bamboo Labs printer.
Ah, nice.
Oh,
AMS2 Pro feeder on it. So,
which model did you get?
the
Printer?
P1S,
Good choice.
and then the AMS2 Pro feeder port. So I said, okay, I'm going to splurge.
Yep.
That was my February paycheck. I didn't work much in February.
You'll like it. You'll enjoy it.
Well, I'm having enough trouble with mine, and I figure, okay, it's supposed to be, the equivalent of a toaster oven where you just turn it on and it works.
Pretty much. Yep.
I said, okay, I'm going to splurge. I've got a couple grandchildren that want 3D stuff printed all the time. And grandpa fails miserably at it.
Yep.
Back when I first got mine and my grandkids were really, really young, they had an operation game in which they'd lost several of the pieces. So it became a joint exercise between them and me to design the replacement pieces and 3D print them. Simple enough and small enough that they didn't get their attention didn't wander until we were done. So it worked out well.
That's neat.
That is a great game.
Okay, I think that was our list of presenters. Did I miss anyone? Is there anyone that has something to present? When we turn it over to open, Mr. Ackley does.
Mr. Name not available.
Yes, Mr. Name not available.
Not available. No, the only
This is Jim in Calgary. I just wanted to apologize for my comment earlier. So I didn't mean to speak out like that. I apologize.
That's fine, Jim. I don't think we captured it on audio.
Okay, but also I wanted to apologize to the group. Okay, thanks.
Thanks, Jim.
Well, I want to,
I want to know what he said.
I'm
mention,
not telling you.
All right.
Yeah, I don't know.
I wanted to put out a challenge for somebody to do a 3D print for me. My wife's car was 20-year-old, and parts are getting harder and harder to find. In fact, it has a manifold, a rubber manifold that cracked and is leaking and causing the engine light to come on, and apparently is not available or findable anywhere. The dealer has checked all of his sources and tried to go into some of the used car, parts places, not succeeded. And let me see if I can bring it on here.
You might have to go to a junkyard if you want the original.
Well, no, he's tried junkyards too.
Yeah.
Okay.
So is this an intake manifold, like on the
Yeah,
intake of the engine?
yeah. How do I get my other computer showing here? I'm sure there's a button here. No.
You want to share your screen?
Yeah, my other screen.
Yeah, there's looks like a little computer with an up arrow.
Little computer with an up arrow. Well, I tried that, and that's what I got.
Mine is right beside the camera.
Pardon?
Click on it and it pops up a window telling you to pick what you want to share. If you turned your camera off,
That's not what I want to do.
you're back, but you're muted.
Does that even give you an icon or not an icon, some way to select another screen or second screen?
When you use the share button, looks like a computer with an up arrow. It'll
Yeah.
ask you, what do you want to share? A screen, a window, a tab. So like I picked whatever monitor I want to share.
Assuming it's on the same computer.
Yeah, if it's on a different computer, then you have to connect.
On the same computer.
Yeah. But on your second screen or something?
Yeah.
I do that all the time. I use the second screen.
Yeah.
Okay.
There you go.
We're getting there, maybe.
Yep, we see it.
Okay, yes. So that's the beast. It's
Is that duct tape there?
Pardon?
I said, is that duct tape there?
Yeah, that's duct tape there that they put on so the engine will run at this point. But it's not a permanent fix. And the problem is that part right there where the duct tape is the part that the rubber has gotten sufficiently hard that it's cracked. And so the challenge is to make that whole beast a new one. And so that's a challenge for somebody that's got really good at 3D printing.
Have you considered sealing up the cracks with some epoxy, some 5-minute epoxy?
No, we haven't gotten that far yet. they, since it's a dealer, they're trying to find a replacement part. My next option is to go to a shade tree mechanic and let him pour some epoxy in there or something like that.
What about putting a good paid GPT in thinking mode and searching for having it try and search like forums and fan clubs and stuff for alternate sources of parts, aftermarket parts and stuff.
That's a good idea. I've been using ChatGPT to do some design work on my robot, and I might just do that.
Yeah, I've had pretty good luck. I mean, it comes up with a bunch of dorky answers, but I've had pretty good luck with it, finding really obscure things.
I own an aging Subaru, and I have found tremendous advice on solving problems by going and searching the Subaru car owners forums. They all tend to keep their Subarus a long time, and so they start running out of parts, and they have fabulous solutions to problems that I would have never thought of.
I think those sites exist for so many different cars. It's really surprising.
Yeah,
there's a club for every one of them.
Yeah, what I found funny when I had my MGB was that when I needed parts for it, no one sold MGB auto parts, like for engines and bearings and all the whatnots. But it turns out the engine that's in those cars is a four-banger that's been around for like 60 years, if not more. And it used to be a diesel engine, and now it's a gas engine. And guess what? All the parts are still the same, and you can go down to AutoZone if you know what part to order and get new parts now that fit your engine. You know, it's amazing.
Okay.
It's amazing.
Some good suggestions. Thank you.
Yeah. With that seam that's running down the center of it, I'd be curious to make a mold or 3D print a mold and get some heavy duty rubber from like Smooth On. I wonder if that would work.
So which part? I'm sorry, I missed the beginning of this. I was in a little fellow's room. So which part of this is having a problem? Where the duct tape is?
Yeah.
Well, yeah. The whole unit there is a piece of rubber that hooks on the manifold, and when they were so it's 20 years old, and the rubber is cracking, and therefore it cracked when they put a new gasket in because it had oil leak.
I got you. So for that bit of rubber part there with the stuff going in and out, what I would do, because I've been playing with a bunch of different things, if we could somehow model that just enough in Fusion, so we can get a mold going on there, right?
Right.
And I wouldn't use epoxy because epoxy is going to be hard.
Right.
That moves. So if you go down to Hobby Lobby, Michael's, all of this stuff, all of these kind of places will have it, or you can just go to Illuminat's website directly. You're looking for something called Amazing Mold Maker. It's a 20A rubber, silicone rubber compound. In fact, I got a bottle or two of it sitting over here. It comes in a 2-part thing. It's about, well, if you buy it online, it's like $35, but if you buy it at Hobby Lobby, it's like $25. So I don't know how they're selling it cheaper than the real people are selling it, but they are. You probably will you'll get about 16 ounces of A and B, so maybe a total of 32 ounces, or maybe it's a total of 16 ounces total. You get 8 and 8, so you get 16 ounces worth of a 20A hardness silicone rubber. So if you can get that thing modeled, pouring it up there, and then using that as a mold, because you don't care, you just use it once, you'll print it again, you destroy it if you want. It doesn't matter, right?
Right.
Just you get it modeled and the way you want it, then pour that full of that stuff, which I bet one of those kits would probably do what you need to do there if you get it modeled good, and pour it up. It'll take you longer to do all that, because that stuff, once you pour it, you got an open time of about 5 or 6 minutes and a set time of about 30 minutes. So you can demold time in 30 minutes and a full cure time in 24 hours.
Okay, tell me again the part number.
It's Amazing Mold, MOLD, maker. You can get it at Hobby Lobby and Michael's there locally. If you need to order it, it's made by a company called Illumalite.
I think he's got a link there, Dave.
Yeah, I dropped a link in the chat, David.
Okay, thanks.
It's red. If you want it some other color than red, I can't help you with that. So actually, I can help you with that. If you want to spend a little bit more money and get Plat 20, which means it's a platinum-based silicone. There's two kinds of silicone, platinum and tin. How do I know all this stuff? I don't know. I've been sucking it in for the last year, and now it's all coming out in weird ways. All right, there's a platinum-based silicone that's clear, and you can get alcohol colorants, so you can color it whatever color you want if you want to actually go crazy about it. But I think a red one of those to see if it's going to work is probably pretty good.
Do you think it's going to handle the underhood temperature range? I mean, it could be.
Silicone is supposed to be good at 500 degrees after it's heated up.
Oh.
You know, it should be, you know, and it should be able to handle that. I mean, when it gets done, it's silicone. So, in fact, I've probably got some of that. In fact, I do.
Dave, the piece that you need to replace, how long is it? Is it the most of the width of the picture you're showing? Or is it only like the size of the duct tape?
It's 2/3 of it. It's about 8 inches.
Okay. So it has multiple holes on it, does it?
Yes.
Okay. So that's a fairly complex piece.
Yes. It is a complex piece. That's
But
why
I'm thinking you can probably, it'll take a little bit, but with Fusion, you should be able to model that up in a way that's useful, I think. And then you got a little cleanup to do, maybe not, and then pour it full of rubber. I mean, there's a chunk of it I cut off. I can't hardly see it in there. And this is I poured too much of it, and it bends just enough, and it's solid. And you know, I think that would do you. I think it'd work if you want to go that route.
well, okay. The thing that I see is I can see how to make the mold for the outer part, but how do you make the hollow center and be able to get it out afterwards?
You just 3D print the thing. You 3D print the thing, and you can do one or two things. 3D print it, then slice the outside in half, band it back together. You know, you could, because in fact, it probably would print pretty good if you did the internal one as a mold and do the external one. And the internal one as a mold pretty much should just be a straight tubes, right? You shouldn't be anything crazy like that, right? And then
On it, they apparently have it bellowed like a bellows.
Yeah, well, okay, so it's a little more complicated than I thought, but I think it'll work. I think it'll work. You might have to do a two-part mode where you end up splitting it apart, but once you get that, if you split it apart, you should be able to pull that apart, so get you to that, and then that internal one might be a little more difficult, but you don't need to make that as bellowed probably on the internal one, just a little bit, and shooting some air down between use your air compressor and shoot it down between it should break that mold loose. It should have enough flexibility for you to get that thing off of there, especially if you coat that mold with mold release, piece of plastic mold.
Well, I see what you're saying. In other words, for the center, for the internal part, just take and expand it off of it.
Expand it off of it. You might have a bit of weirdness going on there because you got those tubes coming out, right? Left and right. But I think if we get creative, we could probably do something. We could probably do something about that.
Okay, see what you're saying.
Yeah. Is it a popular car? Maybe you could recoup some of your expenses and
especially
to other individuals or in that
failure mechanism and be able to sell them.
Yeah.
In my younger days, I got a tail light for my dad's car at the Sears parking lot, but that's when the screws used to be on the outside of the lights.
Because all that rubber stuff, you know, I got cars that are 20, 25 years old. I've been driving a 20+ year old car now for almost, well, they're different cars, but every one of them's been about 20 plus years old for the past 10 years. And all that stuff just goes away. There's and there's my mechanic, which is retired now, and I'm sad about that. There was we had this Montana. The mechanics around the world say this is the worst designed car to work on ever in the history of ever. And I'm going to believe them because of I got a long stories about that. But what happened was there was a water distribution manifold that broke. Literally, it came out of the thing and went to 4 or 5 different directions to go to different things. And that thing cracked in half, spewed water everywhere. It's not like you could drive it anywhere. I mean, in about 2 minutes, it's out of water, right? So it's not going anywhere. So I'm like, okay, let's see how I'm doing that. I got in there and I finally got back in there and fished it out, got it. Cool. Went down to Home Depot, grabbed a bunch of copper tubes and fittings and some propane because I didn't have all my tools, and got in there and copied it up and put it back in there and got it going and down there. I don't know, it must be 6 months, 8 months later. Mechanic goes, Harold, did you make that copper thing back in there with the man? I said, yeah, I did. I didn't have a choice. He goes, no one does that. It's never going to fail ever again. Because it's instead of the plastic thing now, it's a copper tube. It's still the same size as everything I do because nobody ever gets back there to do that. I don't know how you did it. And I'm like, well, I didn't have a choice. That's how it came down. That's how it came down. So I'm getting creative with some of this stuff. And like somebody just said, if there's a market for those sorts of things, you could charge, I don't know. Okay, it's made out of unobtainium. How much you want to charge for it? That's all. That's the deal, right?
Yeah.
There's I was reminded in this of some ad I saw. It must have been some years by now, but there was a time when there was there were ads for this stuff. You get this can of rubber coating stuff, and you brush it on really thick, and they showed it to patch up canoe hulls and flexible things, and it made it seem like it would stick to anything and flex and seal up. So I found a link of the stuff that looks about right in. I put it in to Lowe's there in the chat.
Yeah, isn't it that flex tape, and it looks like duct tape, but it flexes and goes. They put like a screen door on the bottom of a boat and then covered this stuff with it and floated out in the boat, that kind of thing.
Yeah, there's something like that.
Seal.
Yeah.
Yeah. And that might be a simpler solution than all that noise I just spit out.
Or even
cut the crap out of it.
Here's a crazy one. So on the bicycle, they sell rolls of silicone handlebar end tape, or it's long strips. And with that stuff, I was really amazed at how well that stuff closed on each other and sealed up and held. So that might.
Yep.
Let's see if I can find a link for that too.
This is a thing that the original lasted however long. This next one, it's not like you're driving the Baja 1000 with this thing. It's just got to be good enough. It doesn't have to be a perfect thing.
Yeah, I think nowadays you're lucky if you can get parts for a 15-year-old car. It just doesn't seem like they're carrying things forward for much longer than that.
I thought it was legally after the car went end of life 10 years by the American standards, you have to carry parts for it. And after that's whatever that is. If you happen to have parts, I think Carl probably knows this too. I think they call it NOS, new stock that never left the shelf. And people suck that up and hold on to it because of this very reason.
There you go. Self-fusing silicone tape. Now this is a huge roll. It's 1 inch by 12 yards, but you can find shorter ones, I think.
I don't know. Sometimes when you got to put a lot of dead hook. Oh, never mind. That's another old joke. Never mind. Dead hookers in the front. Maybe you need a lot.
Oh man.
Never mind.
But I'm telling you, if that's the stuff I've used on handlebar-like things, it's just amazing how well it fuses to itself and then seals things up. So we'll get you
Is
there.
is that part under vacuum or under pressure?
Probably.
You're muted, Mr. Ackley.
Sorry. It's under pressure.
Oh, it is. Better if it'd be under vacuum, then you could have the tape stuck, suck into from the outside.
Yeah.
What, couldn't you tape the inside of that too?
I guess you could, yeah. A little trickier, but
I wouldn't try taping it. That would
See,
be
we-
almost
we-
impossible.
We
But
were-
they have a Flex Seal liquid that would possibly work.
When the tape lets go or the liquid lets go that you pour in there, what part of the engine does it go into?
the intake manifold, I guess.
What to worry about?
I think
What?
it's the intake manifold.
Oh,
No damage could happen there.
It's just the fuel ejectors. Okay, Kareem is going for the URL obfuscation job as well. That's good.
I thought Carl did a good one, but
I think the obfuscation star goes to Kareem. Yeah. Okay, David. So there you go. We'll get your car up on blocks in the front yard yet.
yeah.
I don't think my wife will like that.
If
Oh,
we
yeah,
go
that's
full
hurt,
of parts.
Well, you could do a herald and forget the exact shape of it and just make whatever connections you need to with.
Yeah,
You
it'll
know.
take a little longer, but
Yeah. Doesn't have to look exactly like the original, but
No.
it may function just as well.
That's the function.
Kareem, I think that's the same link or same product that Carl put in.
Great minds and all right.
great mind.
No, mine was an Amazon link to a liquid, not a tape.
Yeah, the first one he put in was liquid,
Oh, okay.
the Lowe's. And look at his link; it's way shorter.
Well, that one, thanks very much. But
Okay.
Well, you've got a couple
Well,
suggestions.
I am the obfuscation king, so there.
Thank you, everyone.
Incidentally, I copied everything before the question mark in your link, and that works. Okay, do we have anyone else that's got a question or something to bring up?
Yeah, I do.
Oh, go ahead, Mike.
Yeah. So I was going to do the barrel racing, and I'm anticipating how to code it. And being in Ross, it's it would be okay. Well, map out where the cans are, and then create a path, and then feed it to Navigator and have it run it. Yeah, that sounds like a pain in the ass. And the other one is I think a lot of people just pre-code the path and tweak it on site to get it to work. But I've been thinking of since I have a nice LIDAR on my robot, I'll just detect the cans and then just create some code that runs on the fly that keeps the can or keeps the robot a certain distance from the can by using the LIDAR, and it's basically like 90 degrees off to the side and run around it. And then when it gets out of it, you can sort of measure the angle and then detect the next can and then run to its side and run around it. So I'm not sure which is the best way to do it, but I sort of like the idea of just using a LIDAR and saying, okay, make sure that just run at a certain angle to the robot and a certain distance to the can and just run in circles around the can. And then break off and go to another can and do the same thing.
I like that idea. That's a good idea, I think, Mike.
Are you going to compensate for the forward motion of the robot as the LIDAR is spinning, or because it's going to get, changed as it approaches the can? Kind of like what I think Chris did once, right? You actually compensated for that, didn't you?
Compensate. What do you mean compensate?
Well, as the LiDAR is spinning, you're also moving forward, so the distances change based on how fast you're moving forward. And if you don't include whatever distance you've gone and try to compensate the readings for it, the readings aren't going to be right.
Yeah,
They're-
you're
it's
gonna
gonna be
get some
twisted.
distorted view basically, but it's really only an issue if you're moving fast. Even more of an issue if you're turning. That's it's really bad. If you're just moving in a straight line, yeah, the LiDAR scan gets a little bit warped, but if you're turning, it gets really warped.
Yeah, because I was thinking that the robot would be next to the can and I'd just make sure that the can is detected like using the LIDAR 180 degrees using that ray, that angle, and just keep the distance constant around the can as it rotates. But so I'm not sure what problems there'll be, but it sounds like a neat way to do it. But you're saying that I might have some distortion that I got to deal with.
Well, yeah, again, depends on how fast you're moving, and I found it mainly to be an issue with the RAW's navigation stack things.
Yeah, I
that
wouldn't use the navigator.
they got confused by the warped view of the world.
Right. Because I wouldn't use the navigator. I would just basically process the topic from the scan with some simple Python code, and then run the wheel and have the wheel velocity to maintain the distance and the angle.
Yeah, for what you're doing, I don't think it's an issue.
Ah, good. So I was trying to think of how to do it, and there's like 3 ways to do it. I don't like the navigator one where you create a map of the cans and say, okay, got to keep away from these cans or obstacles, and then mathematically create a path and feed it into the navigator and say, okay, run that path. That sounds like it'd be interesting to do, but doesn't sound any fun. So, and it'd probably be slow yeah. So I'm going to try to do it that way using my 6-can robot which has a LiDAR on it that detects the cans. Oh, so I was just putting that out to see what people think, and appreciate the distortion thing. So when I try to do it and it's just going crazy, then I'll have to go in my head and go, oh, I remember people's talked about that.
I was thinking about doing it with vision with blob detection.
With what?
With just blob detection. Like color blob.
Off to the side?
So you want to be, the blob detection, and you want to be so far off to the side of it and wrap around the can at a certain rate. For a turn of whatever it's going to be, 120 degrees or something.
And then break off and see the next can.
And break off and see the next can and repeat.
Yeah. Well, I was just going to use, since I have a LiDAR and the capes and the cans are pretty simple to detect with the LiDAR. I was thinking of using that and not use the camera at all. So yeah, we'll see. So, and anybody else doing the barrel race, or how are they doing it? Like Ray, didn't you do it, or
me? No.
Oh,
somebody did it last year.
That's not Carl. Did you do it
last year? I did it last year.
Oh, you did?
Yeah.
I did not. Doug won it last year.
Doug, do you want to share your approach, or is that confidential?
No, it's not confidential. Can you guys hear me?
Mm-hmm.
We can hear you.
Okay. Yep. No, I just mapped out a course and used odometry to follow it. And if you recall, it was a little iffy because it was, it's open loop, and the car, if the robot doesn't follow the course exactly, you're going to hit the can, because you're trying to, the trick is to try to go fast and go close. All right. So, but I like Mike's idea. I think it's more sophisticated, you know. But I just wanted to, I'll probably run something in that. I'm hoping to have a real nice little platform for 6 cans in it. That would be a great little robot to do that on.
Mm-hmm.
We'll see.
All right.
So do you remember what your time was around the?
It's in the Hall of Fame or whatever on the, you know, so you can see all the results from last time.
Yep.
I don't think it was real stunning. I think it was pretty good though. I was pretty happy with it.
Are we talking about 5 seconds or?
No, you'd have to go out to the website.
Okay.
You know, let's see, that would be under.
Oh yeah, the LIDAR's only 10 samples per second, so I'd have to go less. It's not going to be that fast.
Yeah, I was more interested in completing it without hitting the cans. And here it is. Come on.
Is there a video there, Doug, you could share?
I don't know if there's a. Yeah, mine. It was pretty slow, guys. It was 33 seconds and 33.93 seconds. So that's pretty easy to beat that. So it'll be interesting.
You say that, but until someone does it.
Yeah.
You are the reigning champ.
Yeah, I guess my one thought would be to make sure you get through the course once and then go for speed. Don't try to do your fastest on the first run and mess up.
I want to see one of those walking robots do it.
Yeah.
Wouldn't that be a galloping robot?
That would really be cool, wouldn't it?
A little galloping horse?
Yeah. Yeah.
Mark's making a walking robot, so he can do it.
I'm trying to figure out how to do odometry on a walking robot.
Downward facing, what's that sensor? Optical flow.
That's an idea.
Yeah, optical flow is probably the solution. I can tell you that using average gate, will work for something like there and back, but I don't think it's good enough for really precise location.
You could put a pedometer on it, as it walks forward,
But the problem is when you turn, your gate distance changes.
Oh yeah.
So it gets a little weird.
Yeah. Well, I was thinking to get back to the starting line, before I left on the starting line, I would map out where the cans are, the distance and angle. And then coming back, I would just match that angle. When I'm coming back, I just go to that same spot. Basically, this equal distance or whatever between the two cans, and then a actual distance from the furthest can, or something like that. So if I did that right, it should just go right back to where it was within a centimeter.
Yeah. Well, since that was the first time I ever ran it, and I did not use anything super sophisticated, and I think the first optimization would be to run towards the can really fast, and then as you start to turn, slow yourself down, and then when you get where you can see the other can, just do a speed run over to that side. I think mine ran at the same speed through the whole thing.
I see. Yeah, like in that 6 foot straight path, you could just go fast.
Yeah.
Well, that's all I have. So yeah.
Okay, thanks, Mike. So that's it. Anyone else?
I have a question for any electrical engineers out there.
I are an electrical
Yeah.
engineer, so what you got?
You are?
IR squared.
So as you guys know, I've been working on my mod linker boards. This is the latest revision of it. So one of the things on this board is it actually can take power from 3 different sources. So incoming over the daisy chaining connection, there's a 5 volt. Into the bottom is a
Lift it higher. Yeah.
Sorry.
Yeah.
So into the daisy chaining comes a 5 volt.
Oh
It can
yeah.
also be connected to the USB, which would deliver the 5 volt. You can also power it via 6 to 24 volt on the bottom, and then it goes through a built-in regulator to cut it down to 5 volt. So one of the questions I'm having is if I have multiple of those circuits, how do I protect them against backfeeding each other?
Schottky diodes.
Yeah.
That was the way I did.
Yeah.
That's the simple way for doing it on, which is the way I did on the first board, but you get a voltage drop. So as you daisy chain these together, that voltage drop builds pretty quickly.
Mm.
I'm wondering if there's a way to do it without the voltage drop.
Could you do it with an ideal diode?
Yeah, Doug had some designs for the ideal diode that he made a board for.
Mhm.
Yeah, that's virtually micro ohms.
Yeah, which
But I
is
believe
basically
it'll
an
block
infit.
reverse flow of power.
It's basically an infit.
The diode was mainly to make sure you didn't connect it backwards. Okay. So you can, how much, if your grounds are all the same, Mark,
Yeah, the grounds are all the same.
if you are, then, and you stay within your voltage limits, they should be okay. Otherwise, like if one board is at 3.35 and the other one is at 3.2, you should be okay, as long as they have common grounds.
Mhm.
You don't want to have anything floating. It gets
Yeah.
weird when things float.
Yeah.
Right.
So basically, you're saying each board has a regulator, and you just tie the outputs of the regulator together.
Yeah. Yeah. Are you taking 5 volts off of excuse me, when you power one up, are you using its power for the other boards in any way?
Yes, potentially.
Through what? You mean like
What's that?
I mean, like, okay, so like if you have a board and you're feeding a sensor that's hooked to that board, it'll be fine.
Right.
Yeah.
What I'm worried about is when I go to daisy chain over to the next board. So I might have power coming in. So when I've got the ports, you can daisy chain by basically feeding in on one side, feeding out to the other over to another board.
Yeah.
And so there's a 5 volt that basically will feed that way. So that you can basically power solely off of there. But I can also get a 5 volt from the high power supply that you can hook up to the bottom. So that if you potentially have a 5 volt supply coming from the bottom, as well as a 5 volt supply coming in from the daisy chaining of the boards. And so I'm trying to keep those from backfeeding each other.
Two different supplies?
3, right?
You mean you wouldn't be using you only use one, right? You don't use all 3.
Potentially you can have 2 of them hooked up at the same time. So one of the ways I thought about doing it is by using a power mux IC. And so that's one of the ways that I'm looking into it. And I have done it with the diode. In the previous board, I just used the diode, but then I had the voltage drop.
Yeah,
I would
well,
tell them,
the diode is usually just to keep you from hooking them up backwards and destroying stuff.
Reverse protection. Yeah.
Reverse protection. And you can use an N-channel MOSFET hooked up with, I believe it's drain up to the gate is hooked to the drain, and it will provide you reverse protection. You can check almost look at the circuit diagrams of any Adafruit board, and you'll see how they use a MOSFET to do that.
Yeah.
Yeah, I've got on this board, there's a P-channel MOSFET that I'm using for a reverse.
Okay.
Well, protected if you reverse it. But the problem that I'm having is that if I feed it off of one, it doesn't stop the current from going into the other.
oh,
And so I end up so it doesn't stop the back driving. The diodes stop the back driving.
Yeah.
But the P-channel MOSFET doesn't.
Mark, it sounds like we need a schematic diagram to look at.
yeah. So I'm thinking I would just, since you're going to cable it up and it's not changing on the fly, I would just put power jumpers to disconnect the power. Just put a jumper in there and say, okay, this board is powered locally, so disconnect it from that bus. Or, yeah, that to me that's solid, straightforward and solid.
Mike, didn't you do like a kind of a wired OR with power on one of your boards or one of your designs?
Oh yeah, I just use diodes, but yeah. But they didn't daisy chain them, which is the problem with the diode is daisy chaining, you'd lose more and more and more voltage.
Oh, I thought you'd have like each source go through a diode, and I guess that's what it would be anode, cathode. I guess the cathodes would be connected together, and
if you have two sources, you can isolate them by just using diodes. But if you're daisy chaining them, then you'd have multiple losses. Yeah.
Mark,
oh, that's true.
I'm confused as to what backfeed are you trying to prevent? Is it the backfeed between the onboard 5 to 24 volt input power supply compared to the bus 5 volt power supply, or is it something else?
I'm just, for example, so the simplest way to power the board is basically plug it in over USB. And so the USB provides a 5 power, and if you don't plug anything else into the board, it will provide that 5 power and share its 5 power.
Right.
So then if I bring in a 5 power, say from the bottom through the built-in regulator that I have on it, that could potentially feed back into the USB port.
Okay.
Potentially feed back into the computer. So if it's outputting like 5.2 volts and the USB is only putting out something less than 5, you can basically overwhelm it a little bit.
And that problem is common on every embedded computer board you've ever used that has a USB port on it and a second supply, and they do it with back-to-back Schottky diodes. So you should do this.
Yeah, they do it with the Schottky diode.
They will not cascade. You don't have to worry about that because you're only doing it locally on each of your boards.
One of the things that they are starting to use now are so-called 0 volts drop diodes, which consists of a MOSFET with a certain circuit around it that makes it act as a diode, as if it's a diode, but since it's a MOSFET, it has, very low resistance. It doesn't have a voltage drop.
Mm-hmm.
So are you concerned about a 0.2 or 0.3 volt drop on each of your local boards, which is what you'll get with a simple Schottky?
I'm worried about it for daisy chaining down.
But why are you worried about it for daisy chaining? You're not daisy chaining the local protection. The local protection is only local. It's not between boards. The 5 volt feed that goes along your bus structure doesn't require protection from anything. It just needs a single 5 volt feed somewhere in your network. That's all. and you don't have to protect it from anything else as long as each board is protected from its local supply. And that's not daisy chain. That only takes the 2 shotkeys that are on each board, which are back-to-back connected. You
Okay.
follow? There's no
I think
daisy
so.
chain going on with the protection other than locally, and that's only one diode drop.
Well, and by using these, the MOSFET circuitry, you have 0 volts drop.
Yeah.
Yeah.
But
A
I
lot of
guess,
those are super low RDS on MOSFETs, like, you know,
so
in the
when
million.
you go from one of the connectors to the other connector for the daisy chain, that's just a big wide bus, isn't it? That's all that is. So you're just transferring power over to the next board,
Right.
you know. So I think what Tom was saying is true. You know, you're not, it's not like you're running through the board and then up and then out and then through the board.
There you go. 5 volts. Yep. So basically the diodes are wire ORed, right?
Yeah.
Like that's sort of the schematic that people are talking about here.
Mm-hmm.
Mm-hmm.
And so whichever one has the best voltage will supply the bus. And
Right.
You don't
Right,
really
yeah,
need the
so voltage
diodes up
on-
on the USB line, I don't think. That's,
I think,
you know,
yeah, the diode's built into the USB on the source end, I think.
yeah.
Yeah, so on that, if you've got a 5 volt supply that is, yeah, I don't know, 1 or 2 tenths, okay, 5.1, 5.2, it may compensate for the voltage drop, but it'll also prevent current coming from the other ones because the other ones aren't as high, so it doesn't forward bias the diodes.
Right.
Yeah.
You have to look at the dropout voltage of your regulator too. You know, almost all new regulators have very low dropout, but like if you were using an Arduino, you know, the drop off voltage for this 7505 is like 1.5 volts. So, you know, that's why you shouldn't put 5 volts in through the regulator, because if you did that, doesn't work.
Load.
Yeah, I think you're right, Mike. That looks pretty much right. You know, but I mean, that should be okay.
All right, I'll take a look at that.
Yeah.
Yeah, like I said, the other one that I was looking at is some of the power switching ICs that they use, for example, in cell phones and whatnot, for switching between the battery and another load, to where it'll automatically, it's basically a MOSFET switch that'll automatically switch from one or the other depending on which one's driving.
Yeah, those chips are available, and I think I think you might even be able to use a 18650 one of the 1 amp charger circuits that, you know, the little, you can buy them 10 for $2. You might be able to use one of those because this is a 3.33 bus, right?
It's a 5 volt.
Okay, 5 volts. So you're taking it down to 3.3 internally on each board, right?
Yeah.
Okay. Yeah, you should be fine. So you have 3 regulators going from 5 volts to 3.3, right? 1 on each board.
I've got the regulator on the Pico itself, which basically handles what's coming in from the USB. I have a 5 volt regulator on the on the bottom that basically allows you to power the board from 6 to 24 volts. And then I've potentially got a 5-volt coming over from along the bus line.
Yeah.
So I basically have 3 sources of 5-volt.
I still don't understand why you would be using them all. It would seem to me, is it for
In
flexibility?
theory, you're going to be probably using at most two of them at once. And the reason being is you're going to have a USB on your first board. You're going to probably have a USB connection in to handle the communication.
Yeah.
And so you're automatically getting a 5-volt there. And then if you're actually powering the board off of the high power, say you're driving it at 12 volts so that you can drive your circuitry that you have hooked up to it, like your motor drivers or whatnot, so that you can get your 12-volt for your motor drivers.
Okay.
But that's also delivering potentially the 5-volt just by itself.
Okay.
Yeah, but so if everything's 5 volts and everything's all summed together and maybe a diode for reverse protection, it'll just, the current will come from the
Whichever one's providing the most current. Yeah.
Yeah. It'll just be current sharing, and like the cables going between them will probably be relatively high resistance. So
right.
So if you have a voltage regulator on one of the boards, it would probably get the power from it. Yeah.
Yeah. Typically it'll get from
where is the
voltage.
Why isn't the daisy chained 5-volt supply connected to your 24 to whatever 3.3 volt supply that you have? I'm just curious. Otherwise, one of the things you don't want to do is you don't want to bypass the protection on the Pico board by inputting 5 volts into it, because it's only supposed to get 3.3, I believe.
No, the Pico is 5-volt powered.
Yeah, but the signals on that daisy chain bus would be 3.3 to keep it simple, right?
Yeah, I mean
the signals are 3.3, but the power is 5-volt.
Right.
Yeah, but it uses an onboard regulator to.
You're talking about using the onboard regulator, right?
On the Pico.
On the Pico.
Or
you're not
to
going.
get it down to the
There's not
3.3.
something like labeled VN, which is expecting really a pre-regulated voltage. You don't have anything like that. I can't remember. I haven't played with the Pico that much. So
the Pico is designed to be powered by 5 volts. So whether you're powering it via the USB where it takes in 5-volt, and then the Pico has its own regulator on board that basically takes it down to the 3.3.
Right.
Yeah.
So there's nothing powered by 5 volts directly, no circuitry. Yeah.
On the Pico itself?
Well, right. And everything on the Pico is 3.3 volts.
Everything on the Pico is basically 3.3 through it. And the Pico is relatively protected.
Right.
The Pico has the Shakti diode on it, and so it doesn't allow the back. If you wire it correctly, if you wire it correctly, the Pico is protected. It actually has. There's 2 power pins on the Pico. There's the VBUS and the VSYS. If you power it via VSYS, it's protected. If you power it via VBUS, you can actually backdrive the USB, which would be bad.
I'd be kind of curious. Do you have one of those, it's like a USB little meter, current, voltage, power?
No, I don't have one of those, I don't think.
They're very handy. Basically, it has a little color display on it, and it tells you, voltage of your laptop's, USB output voltage and current and power. And so it's, if you plug in your thing and all of a sudden the current jumps really high, then oops, something's wrong here.
I have a USB isolator. It looks similar to that, but it cuts off the 5-volt power going to the computer.
Right.
Oh, okay.
So that you've got an existing circuit that's powered up rather than backfeed the USB. It isolates it from the laptop.
Yeah. So you only have a ground connection and the 2 data lines.
Connection and your data connections.
Yeah.
And it comes in a similar little plastic shelled connector like that.
Mm-hmm.
Because not everybody makes good circuit boards that have proper
Protection on them.
protection.
Yeah. Yep.
Including me. So when I'm troubleshooting on the robot and you're tied to a Arduino Nano being fed from something else, well, it's in handy.
Yep.
That was my solution. Rather than try to isolate it, I just blocked it.
Yep.
Okay. Well, thanks for the ideas.
Any other questions?
Hey, Pat,
Yeah.
I did actually find that little video if you guys want to see
Yeah.
it.
Play it.
Yeah, let's see.
That was the best run ever so far. So it's worth playing.
Oh, no, not that.
Oh,
The parade float.
Oh,
Yeah,
the
the
parade
parade
float.
float.
Oh, I was all excited for the barrel racing.
See, now you got to remember, this is not from this contest. It's from some other contest, but you kind of get the idea of they want you to decorate it. You know,
Just in
this would
time for
not,
Mardi Gras.
this wouldn't pass their rules. But anyway,
Can we throw a little advertising on it? You know,
Mm-hmm.
DPRG.org on the side of it.
yeah.
so Doug,
NASCAR it up, baby. NASCAR it up. Put a wing on the back, it'll go fast.
Yeah.
so Doug, to maintain distance, I guess the one that's following the one in front is one that maintains the distance, and you don't have to worry about what's behind you because that one should maintain its distance.
Well, I guess it would depend. You probably want some sort of buffer from the one in front. Okay. Now they did say, well, you want a micro switch. You could use a micro switch. Well, that's obviously right up on his bumper. But if you wanted to like leave 2 inches and you see the guy closing on the back of you and he gets within 2 inches, you might want to scoot up an inch. You know what I mean? I mean, I'm just saying there's some strategies you could use to try to
I think
keep
it needs an air horn too, in case it gets too close. You know, just
Yeah.
hit the air horn.
Torpedoes.
Yeah, I like that one.
Little taser.
A little plunger rod that goes out and pokes them, you know,
Yeah.
like stay back, stay back.
The solution with those little air shot BBs.
Oh,
But I thought when you described the rules, you had to maintain a specific distance between them.
That's a good question.
it sounds like they do, but
Yeah, I think you can only control your distance in front, right? I mean, you can't control the robot in back, so
Torpedoes. You're getting
so
too
maybe to
close.
let them know with the air horn.
They do
The
give
BB
a speed. They say you should go between 190 and 220 millimeters per second. So that's essentially
20 centimeters. So just under a foot, about
two
9
thirds.
to 10 inches. Yeah.
so you got to be moving. You got to be moving pretty fast.
Yeah.
4 inches a second.
They say in
190 inches a
200 millisecond, 200 millimeters per second.
Yeah. 8 inches per second.
That's pretty
So I
cool.
assume that the lead cart would be setting the speed of all the others down.
Yeah.
So basically they're saying you need to be able to keep up with the lead cart.
Yeah. Well, I'm certainly game to help out on that, Doug.
Okay. Well, let's think about it because I really would like. Be nice it'd be nice for us to go to another event and advertise DPRG a little bit.
Yeah, for sure.
I
It's in a
probably
month,
put an
right?
ultraviolet sensor on it. Not ultraviolet, but an ultrasonic sensor. Real simple ones.
So it's in a month, right? So about 4 weeks time. So
Yeah.
just gives a timeline. It's pretty quick.
So are you going to meet this Tuesday, Mark? Is that the plan for your for the
Wednesday?
Robbie?
No, we met last Wednesday. We can meet this Wednesday. I'll be there tomorrow. But next Wednesday was the planned get together. We met last Wednesday. I'm doing every 2 weeks, so next Wednesday.
So
But-
you're
but
talking. Let me ask you: are you talking like in 2 days? I mean tomorrow, or are you talking in a week?
Officially in a week, but I will
Okay.
be there. I will be there tomorrow night.
Okay.
So if you want to meet tomorrow night, we can.
Okay. Well.
Or if you want, I can just swing by your door and knock on your door.
Okay.
Actually, if we
We
did
could,
that, well,
Yeah, we could use the mini Sumo robot, which has a sensor on the front, a time of flight sensor, and sort of decorate it.
Oh, I thought you said maybe push it out of the way.
yeah, I got my little Zumo too. If you need that.
Okay. Well, let me see if I can make it over there. I'm not sure I can make it this week, but we definitely for on the 18th.
Well, say if not, I can come to you because I'm in the office tomorrow, so I'm out there.
Okay.
Yeah, I was going to go to the Comet Clash and put in my mini Sumo on Saturday.
Is that this Saturday coming?
I believe so.
Ooh,
I think
let's
so.
go see that.
Let me see. I thought it was. Everything's coming up fast. I was out of town.
Yeah, you blink, you miss it.
Yeah, March 14th. Yeah.
Yeah.
Then I
I'm
gotta-
guessing.
Then I gotta leave soon and go to a theater thing for my rotating platform. I got to demonstrate it at 12:30. So I'll be running around.
Very nice. What time's the thing on Saturday? I might go to that. Can you post it in the Discord again, Mike?
I have to go. I have to go look at their Discord and see and
Okay.
get it real precise.
Yeah.
'Cause
Yeah,
for
'cause
some
if you
reason,
go-
somebody's gonna say 8 o'clock in the morning, so it's early morning. But
Yeah.
maybe I'm
Okay.
wrong.
I'll come along and be a cheerleader.
Oh, you got yours to bring?
No. Mine has not moved since we battled.
I broke it.
No.
No.
I just haven't had time to mess with it.
Ah.
But I mean, you could have broken it. You came in pretty heavy. Yeah.
Comet Clash. I'm looking at their Discord site.
Okay. Yeah, I guess I can look at that comment. Duos.
Anybody else's internet been affected? Mine just died, but came back apparently.
Was that right?
We're having storms here, and
I haven't
Yeah.
heard any
Yeah,
down
mine's-
here.
Mine
What?
has dropped a couple times.
oh, has it? Yeah.
Not heard any storms. I think you got them all.
Oh, all the storms.
Yeah.
Yeah.
I think you're north of me, right? I'm in the colony, so you're
Okay. I'm seeing it. It starts at 9 o'clock, and I think I can copy this and put it in here. Let me see.
Why don't you put it in the Discord server? Then it'll be out there for anybody that wants it.
yeah. A Sumo thing, but I don't see it. Announcements.
So, okay, which one? Off topic. Navigation.
So this is a sumo competition somewhere.
So this is outreach. Okay.
At UT Dallas.
Yeah.
Okay.
Yeah, it's the one that we went to a few months back. Really, really fun place. Some real smart minds. Yeah. Thanks, Mike.
Mhm.
Whatever happened to the guy that was designing a micro mouse robot? Did he compete?
Oh, yeah. I haven't seen him.
He was supposed to compete in March, and we haven't heard from him.
Hmm.
I thought it was March.
Yeah.
I thought that would be good for barrel racing because they're supposed to be fast, those micro mice.
Yeah.
Mm.
And it has a good front sensor, so or it needs a side sensor though. Yeah.
Wow.
Yeah, maybe that's it. You just need a side sensor, and when you pass by it, you know, to
Okay,
hang a
left
right. Do it 4 times, and you're done. You know.
Okay, guys.
Yep.
All right.
Time.
I think so. That was a good meeting.
All right. Good night.
Night.
Good night.